teaching of numbers and operations. Can you see my whiteboard here?
Yes.
Okay, so we are going to start off with process standards for mathematics. Okay, what are process standards for mathematics? And then we're going to look at effective pedagogies for mathematics, how we are going to teach using the connection model. And when we use the connection model, there are two different strategies that are related to the connection model. That is the Thinkboard and the concrete pictorial abstract method. Okay, this one we're not going to do. And then we're going to look at mathematical reasoning via investigations of conjecture and learning mathematics via multiple intelligences. These two we will do next week. Okay. Okay, let's look at effective mathematics teaching. Okay, these are the process standards for mathematics. These process standards are in the DSKP. That means all teachers have to teach mathematics using these processes. Okay, so all teachers in all primary schools, okay, they will follow the DSKP. Okay, so what I am sure you already know what is a DSKP, yeah? So the contents of the DSKP you will learn in MTES 3063, okay? In MTES 3063, you will learn what is the DSKP, what's the purpose of the DSKP, what are all the different areas, and what is the content for each year that you have to teach. Okay, all that you will learn in that subject, okay? So in fact, this also I think you will learn this topic, process standards of mathematics. Also, I think you will learn in MTS 3063. Okay, but I'm just giving you a general overview only. Okay, so this topic you will find it in the DSKP. So all teachers have to teach mathematics according to the process standards for mathematics. And there are 5 process standards: mathematical representations, connection, reasoning, communication, and problem solving. That means when you teach mathematics in primary school, you have to try to teach using mathematical representations by building connections, using reasoning strategies, which you have already learned this, okay, and using communication and problem solving, okay. So let's just have a look at the DSKP, okay. Okay, this is the DSKP for year 1, it is in English. So all DSKP in the front, I've taken off a few pages, okay? So I've come to this page here. All DSKP in the front, at the front of the document, they're all the general things that you have to know, okay? And here they have given you that emphasis on the development of mathematical thinking is built and developed through the teaching and learning in the classroom based on the following principles, which are problem solving, communication, reasoning, relationship making, representations, and using technology. Okay, if you look at this diagram on the right here, these are the process standards in the teaching of mathematics. You can see there are 5 process standards here. Okay, so this is what that we have to know. So you can go and read more in detail about that in the following page. Okay, we know that the learning areas for primary school is divided into 5 major learning areas. This is bidang utama. Okay, so we have numbers and operation. This is the largest learning area, okay, comprising of many topics. Okay, and then we have measurement and geometry, relationship and algebra, statistics and probability and discrete mathematics. Okay, our course here will focus on these numbers and operations only. Okay, the next course that you will be doing next semester, it will focus on the other topics of the primary school syllabus 3093. Okay, 3093 you will learn all this. For 3073 we are only focusing on numbers and operations. Numbers and operation means all kinds of numbers, numbers, whole numbers, fractions, decimals, percentages, ratios, all that come under numbers and operations. Okay, so to teach all these areas, okay, to teach the mathematics curriculum, the mathematical processes that support the teaching of these topics are all these 5, okay. So in order for you to learn more in detail, you can read here, okay. Problem solving, they've given you what is problem solving and all that. You can go and read. Reasoning, what is reasoning? Communication, Okay, what's communication, representation, and connection. Okay, so this I've already put these notes in. I've just taken it from here from the DSKP. Yeah, I've already put it in the GC for you, so it's easy for you to go and read. So all you have to do is go and read that, and then later or tutorial 2 in your groups, which you have already formed your groups, you create a mind map depicting the process standards for mathematics. Just do a mind map, pick out all the important things and put it in one page. Okay, and hand it in. One group only hands in one because this course is so heavy. So tutorial is not individual for this semester. Okay, so all tutorials will be in groups. But because you have 30 hours of tutorial means that you must send in your tutorial to show that you have done something for the 30 hours. Okay, so this tutorial too, you only need to do this on tomorrow. Okay, this is for Wednesday the second hour. Okay, you need to do and you can hand in by next week lah. Okay, any questions so far?
No, madam.
Okay, so now we're going to continue with the next topic. Okay, we're going to continue with connection model. Okay, but before we look at the connection model, we want to know why we need to learn the connection model. Okay, so the connection model of learning mathematics, it actually encourages relational understanding. Okay, there are two kinds of when we teach, we aim for two kinds of understanding. One is relational understanding and the other one is instrumental understanding. Okay, relational understanding means you understand the concept and you can see the connection between the concepts. Okay, instrumental understanding means you understand the procedure, you understand the steps how to do, you understand the rules, the algorithm. That is instrumental understanding. Okay, many teachers teach for instrumental understanding. Okay, but before that we need to look at mathematics knowledge. Okay, what is mathematics knowledge? Mathematical knowledge can be divided into two types. You can have content knowledge and pedagogical content knowledge. As a teacher, you need to have both. You need to have content knowledge of the primary school syllabus. That means you must know what is whole numbers, what are fractions, everything you must know that already. Okay, that is content knowledge. Pedagogical content knowledge, also known as PCK. This is known as CK, content knowledge. This is, you will see many places PCK. Okay, PCK means pedagogical content knowledge. Pedagogical content knowledge means the knowledge of how to teach the content. Okay, that is what we want to try to give you in this course. Okay, so as a teacher, you must know content knowledge and you must know pedagogical content knowledge. Okay, so what is content knowledge? This content knowledge is in the DSKP. For every year, there is a DSKP. And in the DSKP, they have listed out all the learning objectives. Okay, they have listed out all the learning objectives or learning outcomes. Okay, these learning outcomes can be divided into three types. They can be either factual knowledge or conceptual knowledge or procedural knowledge. Factual knowledge is facts. If facts that students must know, like basic facts of addition, basic facts of multiplication, these are all factual knowledge. Students must know. Okay, and then we have conceptual knowledge. Conceptual knowledge is like the meaning of fraction. When you say when they write there in the DSKP, the learning outcome is for students to understand the meaning of fractions. It means they have to have conceptual knowledge. So when you teach also, you must teach for conceptual knowledge. Okay, and then there is procedural knowledge. For example, addition of two proper fractions. That you want students to learn this. Okay, addition of two proper fractions. So that this we have steps on how to do this. So we have langkah-langkah. Okay, so this is called procedural knowledge. If the student know how to do this step by step, that means they have procedural knowledge. If the student knows, understand why you're doing this, That means they have conceptual knowledge. Okay, so when we teach, we always teach for conceptual knowledge. Okay, so relational understanding is knowing what to do and why you're doing it. That is relational understanding. Instrumental understanding is knowing the rules, but you don't know, you may not know why. Okay, knowing the rules and having the ability to use it. Okay, so if you know the rules and you know how to do the algorithm, then you have instrumental knowledge. But if you know how to do this and you also know why you're doing this, that means you have relational understanding. Okay, so when we use the connection model, we want to teach for relational understanding. Okay, we want students to understand why they're doing this. We want them to understand concepts. Okay, we want them to have conceptual knowledge, okay, in addition to procedural knowledge. So that is why this connection model came about. Okay, so far okay. Any questions?
Okay.
Okay, so now we look at the connection model. This is a very interesting model. Okay, okay, the connection model of learning mathematics. Haylock and Cockburn, 1989, they suggested that effective learning takes place when the learner makes cognitive connections. Okay, so they offered a simple model of learning based on connection as shown below. Okay, so this is the model of learning, connection model. We call this the connection model. Okay, so as you can see, there are 5 stages in the connection model: concrete manipulative stage, pictorial stage, symbols, language, and context or real life. Okay, so the connection model says that when you teach mathematics, you have to give students experiences, learning experiences in all the 5 stages. Okay, you must take the students through all the stages for them to learn just one concept. Okay, let's look at what is concrete manipulatives first. Okay, so what do you think are concrete manipulatives? Anyone? Yeah, I'm just going to minimize this for a while. Okay, yeah, I'm sure you know what is concrete manipulatives, right? Can you give me any examples?
Blocks.
What's the example?
Blocks.
Yes, blocks. Okay. Okay, sorry. Okay. So can you see my board here? Yes.
Yes.
Okay, so concrete manipulatives are things like base 10 blocks. Okay, you have seen this before already. Okay, okay, what do we call this?
Uh,
What do we call this? Anybody? Counters. We call this counters. Okay, so these are all concrete manipulatives. Concrete manipulatives are things that you can see, you can touch, you can move it. Okay, you can, we call that manipulate. You can manipulate it. So these are concrete manipulatives. These are tangible items. Okay, okay. Concrete manipulatives, there are 2 types. They are proportional and non-proportional manipulatives. Proportional means this base 10 blocks here is a proportional manipulative. So why? Say I have 10 ones here. Okay, this we call this as ones, 1 unit or ones. Okay, so I have 10 ones here. If you can count this, you know there's 10 ones here. Okay, and this piece here is a 10. This is a 10. This represents a 10. This represents 1. Okay, if I take 10 ones and put it together and I measure it with the tens, they're exactly the same length. Correct, they're exactly the same size and the same length. So therefore, they are proportional. If I take 10 of this, okay, if I take 10 tens, okay, if I take 10 tens and I put it together like this, I know 1 is 110. So 10 tens will be 100, right? and I take one piece of the 100. This is the 100 flat, okay, and I put it on top of the 10 tens. They are exactly the same size. That means this model is proportional. 10 ones is equal to 110. 10 tens is equal to 100. So this model is proportional. Okay, you can understand that? Yes?
Yes.
Okay. But if I use a model like this, say I want to teach ones, tens, and hundreds, okay? This is called a place value chart. Normally we use this place value chart with the base 10 blocks, okay? But I can also use something like this, okay? Say I use this, okay? Okay. Can you tell me what number is this? Anyone?
132.
100.
132.
Yes, 132, correct. We have the same size of the chips. We call it chips or counters. We have the same size. Only thing that's different is the colors are different. So for ones, I'm using green. For tens, I'm using yellow. And for hundreds, I'm using blue. So this is also called chip abacus. Okay, we call this chip abacus. This model is non-proportional. You see, the ones and the tens, they are the same size. Okay, they are same size. Because in my mind, I'm thinking 10 is 10 times bigger than the one, right? But here, it is the same size. The tens and the hundreds, they are exactly the same size. Okay, what is different is the color. And because I'm using this place value chart, so I know they are different. So therefore, this model is non-proportional. Can you understand that? Yes?
Madam.
Okay. Sorry, yeah. I need to go back. Okay, let's go back to our whiteboard here. Okay. So that is concrete manipulatives. So concrete manipulatives, they are tangible, okay? Tangible means we can see them, okay? And you can manipulate them, okay? They are tangible, you can manipulate them. They are real objects, they are physical objects, okay? They are physical objects, okay? They could be structured or unstructured, okay? So the second stage here is pictorial. Pictorial means we are referring to diagrams, images, graphs, and so on. Okay, these are pictures. All these come under pictures. Symbols means we are using numbers. When we teach using numbers or symbols, notations, okay, and also words, these are called abstract. Symbols or abstract. Okay, whenever we use excuse me, whenever we write and teach, when we write on the board, we use words and symbols, we are teaching abstractly. Okay, so this is the symbols stage. Language refers to math vocabulary. Language refers to math vocabulary. Yeah? Context or real life is kehidupan sebenar. Okay, we also call these stories or word problems. We can say word problems, all these come under context. So when we teach, okay, according to the connection model, they say that when you teach, you must give students experiences in all these different stages. And when children learn through experiences in all these different stages, what they learn is very deep and meaningful. Okay, so this concrete manipulative stage is also known as the doing stage, because children manipulate themselves. Okay, doing stage. Pictorial is also known as the seeing stage. This is the visual stage. The diagrams, the teacher can give the diagrams to the student, or you can ask the students to draw the images of the concepts that they are learning. Symbols here is known as the abstract stage. Okay, abstract is the last stage that we should teach usually. Okay, language here is the math vocabulary stage, and this context or real life is the stories stage. So there are 5 stages here according to the connection model. So you can start anywhere in this model. Okay, you can start from concrete or you can start from pictorial stage, whichever stage you want. But a general rule is that when you're teaching the concept for the first time, you should always start with the concrete manipulative stage. Okay, let the students learn through concrete activities, and then they can learn, go to pictorial, or they can go to real life context, or they can learn language. From language they can go to pictorial, or they can go to symbol, and so on. Okay, any of the other relationships can take place lah. So if you look here, there are so many connections. Okay, how many connections are there in this model? How many connections can you see?
10.
Yes, there are 10 connections here. So that means there are 10 ways that you can teach, okay? This is a very good model for teachers to plan how they want to teach mathematics and to carry it out in the class, okay? So there are 10 different connections that you can teach with in the classroom. But teachers in schools generally, they only focus on one connection. Can you tell me which connection is it that they usually focus on? Anyone?
Symbols, language.
Symbols and language. Okay. Symbols and language. Okay, yes. Symbols and language. Okay. Um, but there's another one that's very more popular than that. This one. Most teachers will teach this one alone. Symbols, definitely. Okay, they go into the class first thing, symbols. They straight away write on the board and they start teaching using symbols. After they taught the steps, algorithm and all that, straight away they give you problem solving. Okay, because the topic, every topic in primary school has problem solving. So straight away they give you problem solving. Symbols finish, doing the algorithm finish, straight away give you problem solving. Finish, end of the topic. Okay, so most of us, many teachers focus on this symbols and real life only. But there are so many other connections that we can focus on. So this connection model is actually giving you an idea on how to teach mathematics in a very meaningful way. This is how we want to teach for relational understanding. Okay, if you want to teach only for procedural understanding, then symbols to real life is enough, or symbols to language is enough. Okay, but if you want to teach for relational understanding, if you want the student to understand for life the mathematical concept, then this is how you need to teach that, using all the different representations. We call each stage as representations also. Okay, this is the other term that we use. Okay, representations. Okay, supposing you wanted to teach this 4 minus 1 over 8. If you wanted to use this connection model to teach, how can we start to teach? Where will we start? If you're teaching for the first time, you will start the concrete. Okay, let's start with the concrete. How can we teach this 4 minus 1, 8?
Pizza.
How? Anyone want to explain? How will you teach using concrete manipulatives? What concrete items will you use? Concrete can be real things also, real physical things.
By using
Thermometer.
Using what?
Thermometer.
Thermometer.
Yeah, because the only thing that I think about they have negative value.
Oh, okay. Okay, maybe you can. I'm not very sure how to do that, but I think it's like a bit difficult for student to understand, because you are at a level where you understand the negative value, okay? But here we are focusing on minus 4 minus 1/8. Okay? Okay, let's try something else. Anyone else?
Real pizza.
Pizza. Okay, you would use a pizza. Okay, correct. Right? That's one good idea also. Okay, you can take a pizza. Student, you see, student need to understand that this 4 here, it refers to 4 whole numbers or 4 wholes. So that means there must be 4 pizzas, or you can even use an orange. Okay, something that you can cut. Okay, you have 4, and from here they need to understand that minus actually means take away. Okay, take away. How much you want to take away? 1/8. Okay, so from here we can ask them to show how they will take away 1/8. 1/8. Okay, and from here only you teach them how to take away one. I cut the orange, I cut the pizza, take off one part here, and then they can see how much is left. Okay, when you do this activity repeatedly with other types of manipulatives, maybe you can use a cake, you can use a pizza, you can use oranges. Okay, and after that you can start using like blocks. Okay, you can start with real things and then use blocks. Okay, so you teach this until they understand. After you finish, then you give them pictures. Okay, you give them 4 circles and ask them to take away 1/8 pictures. Okay, let them do pictures. You can start with circles or you can use rectangles, any geometric shape. Okay, and then you teach them how to do it in. From here you relate it to the writing. So you see 4 here, so 4 take away 1/8, how much? 4 take away 1/8, so this 3 you don't touch, so you know you already have 3 plus how much. Okay, so you relate from pictures to abstract, and then you teach them the algorithm how to do it. Okay, as you're teaching, you're also using language for whole numbers. For fraction 1/8, 1/8 is the language. Language can be verbal and written. When you write down 1/8, you're bringing in language. Actually, when we teach mathematics, language always comes in. Okay, we cannot run away from language. Okay, after they finish this, then you give them an application question or a story in real life, where they can solve this same question but in the form of a story. So now you have taught them in many different ways. Okay, that is the purpose of the connection model, to give the student experiences to understand the concept in many different stages. Okay, we are actually teaching the same thing. We're only teaching this 4 minus 1/8, but we are teaching using concrete manipulatives. We are teaching the same thing using pictures, using algorithms and language, and using real life stories. So the one thing we are teaching in many different ways. So do you think the child will understand this better, or just learning one method using symbols alone? Okay, so definitely this is a much better method. So when you plan to teach in the classroom also, you must have this model in mind. So when you want to plan a mathematics lesson, you must ask yourself, okay, what concept am I going to teach today? Okay, can I start with the concrete manipulatives? First activity, concrete manipulatives. Second activity, using pictures, visual aids. And then maybe you want to go into algorithm, teach them the algorithm. Finally, enhancement, you give them real situations. Finish one lesson. Okay, so this model helps you to plan your whole lesson. At the end of the lesson, students have many different kinds of experiences in all the different types of stages. Okay, so this is the connection model. It's a very useful model for mathematics. Okay, class? Okay, so now okay, this connection model, there is a, okay, we're going to look at the CPA method first later. Okay, this connection model, there are other connection model is the overall model. Okay, it's a general model. Under the connection model, we have several other strategies. Okay, so we have 2 different strategies that we want to learn under this connection model. That is Thinkboards. Thinkboards are tools, okay, that follow the connection model, based on a connection model, and the other thing is CPA method, CPA model or CPA strategy. Okay, this is a very important strategy that also follows the connection model. Okay, CPA stands for concrete, pictorial, and abstract. In the connection model, you can start anywhere at any stage, but in the CPA model is fixed. You start with concrete, followed by pictorial, and then abstract. After you finish abstract, you can go back to concrete and pictorial and all that, but you always start teaching the concept with concrete. Okay, this approach is being used in Singapore. Okay, Singapore schools, all mathematics teachers in Singapore learn CPA method. Okay, all of them use CPA in all the primary schools in Singapore. Singapore only has one teacher training university. Unlike here, we have 27 teacher training colleges. Okay, so since we have 27 teacher training colleges, although the RMK is the same, but the way we teach in each college, the way the lecturers teach in each college, is all different. So our teachers actually they go out with they teach differently. Each school will teach differently. Okay, because we don't have a module that says you must do it this way. Unlike Singapore, any teacher in any school, the student can transfer it to any school. They don't mind because they know that the teachers will all teach in the same way. All the textbooks, all resources are based on CPA. If it's not based on CPA, they don't buy and they don't use. Okay, it is. I'm just trying to tell you how important this model is in some countries. Okay, and as you know, Singapore is right now in mathematics. They are the top. Okay, and if they are using this method, that means there must be some reason or some benefit for this method. Okay, so we need to pay attention to this method. It's a concrete pictorial method or CPA method. Okay, so it's a 3-step instructional approach that has been found to be highly effective. Okay, highly effective in teaching mathematics. First step, concrete stage, also known as the doing stage. Okay, that involves physically manipulating objects to solve a math problem. Second stage is the pictorial. Concrete stage, usually we use 3D. Pictorial stage, usually, because it's pictures, is usually 2D. Okay, so pictorial is the next stage. It is the seeing stage. We can either use images or we can get the students to draw images. Final stage is the abstract stage or symbolic stage that involves using numbers and symbols to solve mathematics. Okay, so when you want to use this CPA model, first we teach the math concept using manipulatives. Then we allow the students to practice using manipulatives, and we try to use as many different manipulatives as possible. Once the students understand the concept at the concrete level, okay, when they can solve it just using concrete alone, nothing else, no written work at all. Okay, and then only we introduce pictures to represent the objects and we model the concept. Let students practice this visual model first. Okay, and then if they understand, only then we start to use numbers and symbols. That means only then we start to teach them in the written form. Abstract means written form. Okay, so we cannot start to teach written form until the student have mastered the concept using manipulatives and pictures. Okay, so that is the CPA method. Why we use CPA? Because it provides students with a structured way to learn maths concepts. They are able to build better connection. We want students to build connections when they learn, because according to constructivism, students don't just absorb what you're telling them, they build their own knowledge through their own learning experiences. So we must give them the learning experiences. CPA focuses on 3 stages: concrete, pictorial, and abstract. Okay, while the connection model that you see just now had 5 stages. So this is part of the connection model. You're still making connections between concrete, pictorial, and abstract to learn. Okay. Research has proven that this method is very effective. You can use it for any grade level up to high school. Also, you can use it, okay? It helps students to learn concepts before learning rules, okay? When we use the CPA model, we are teaching students the concepts first before we teach them the algorithm. So that's why learning is very meaningful, okay? So this is the CPA method, okay? Now we're going to look at the last thing here that we're looking at is the Thinkboards. Okay, Thinkboards are a very useful tool that model the connection model. Okay, it follows the connection model. Okay, according to Halo, he said that Thinkboards promotes connections. Okay, promotes connections between representations of mathematics, that is written and spoken words, pictures, diagrams, real things, and symbols. Okay, so Thinkboard actually promotes the connection model, the 5 stages that we saw just now. Okay, it promotes understanding by increasing the extent and connectedness of representations in memory, develops a strategy for forming students' own elaborations of mathematics. Okay, how do we use Thinkboards? Okay, we design a large piece of card divided into 4 sections. Okay, each section displays the same mathematical idea but using different representations. This is an example of a Thinkboard here. We have concrete here. We have real. Real here is real life, real life, or we can even label it as stories, or we can even label it as word problems. Okay, how you label is up to you. Okay, then this is picture or visual, and we have symbol. We can also have one more here, language. Okay, how many parts you want is up to you, but this is something like this Thinkboard. Okay, so we use this Thinkboard to teach concepts. Okay, it's a very useful thing. Okay, okay, I'm going to show you an example of the Thinkboard here. Okay, so can you see that?
Madam,
Yeah.
Madam should pin your camera so we can see.
What do you say?
Madam should pin your camera.
Okay, sorry. Yeah, she told me that just now. Okay, sorry. Yeah. Okay. So now can you see that?
Yes.
Okay. So this I have here a Thinkboard. Okay. This I have made on an A3 paper and I've laminated it. So I have like say 10 of these boards. So if I go to class, I just take these 10 boards and go. So if you want this Thinkboard, you can use it to teach any concept. It is very useful to use at the beginning of any concept that you're teaching. Okay. So say, for example, I want to teach numbers 1 to 9. I'm teaching numbers 1 to 9 and I want my children to understand. I want to teach them using the connection model, using this Thinkboard, and I want them to really understand what it means. Okay, so what I want to teach is 9. So 9 is the symbol, right? So I want them to know that 9 looks like this. Okay, and this is 9. So this is 9. So I'm going to write the language here, 9. All right, this is 9. But what is 9 for them? Okay, so I want them to know 9. So I'm using 9 units here, 1 2 3 4 5 6 7 8 9. Okay, so they can count this, they can move this, and they can play with this. They know they can connect here. Okay, so when they keep on looking at this, they can connect between the symbol, the language, the math vocabulary, and the concrete representation. Okay, so they can connect. 9 means there are 9 of this. So if it's 1, they will know it is 1. As you teach them the numbers 1 2, they can see that as the number gets bigger, it increases. Okay, and then I can have a picture of a 9. Say I want to have a picture of a 9. I can draw a number line here, 0 1 2 3 4 5 6 7 8 9. Okay, 9. This is 9. This also means 9. Okay. Maybe in the beginning, the teacher can give examples how to do. But once you've done this a few times, you can just give the child just 9 and they can fill everything themselves. Okay. Story can be, I have 9 sweets. Okay. I have 9 sweets. Because we just want to show 9. Okay. I have 9 sweets. Story. So this way, I have used this Thinkboard to teach the symbol 9. Okay, what 9 means. Okay, so I've used it. I've taught 9 using symbols, using language, pictures, stories, and concrete. So by teaching like this, you're giving the child learning experiences. Okay, learning experiences in every stage, which means they will learn it very deeply and meaningfully. Okay, this is one method of using the Thinkboard. Then there is another way of using this Thinkboard. Here I have an empty Thinkboard here like this. Okay, I have not put any of the labels there because I'm going to use it in a different way. Okay, so what is 9 for me? Okay, so let's say I have 9 here. 9. What is 9 for me? Okay, I can say that 9 is, this is 9 for me. Okay, 9 is 3 rows of 3. This is 9 is 3 rows of 3. 9 means to me 3 rows of 3. Or 9 is 3 groups of 3. 9 is 3 groups of 3. This is also 9. Okay? 9 for me is an array model here. 3 rows of 3. Or it is 3 groups of 3. That is 9 for me. What else is 9? I can say that 9 is 1 plus 8 is equals to 9. 2 plus 7 is equals to 9. 3 plus 6 is equals to 9. 4 plus 5 is equals to 9. Okay? Or I can say that I know 9 is after 8. And I know 9 is before 10. Okay? 9 is after 8 and 9 is before 10. This is 9 to me. So I have represented 9 using different representations. They all give me an understanding of what is 9. So Thinkboard can be used in this way also. Okay, you can do different representations of the same concept. Here the concept is 9. So I'm doing different representations of the same concept. Okay, so this is one example of a Thinkboard, or you can use this as your Thinkboard. Here the 5 stages are very clear. You can see the 5 stages very clearly. Okay, so any questions here? All okay? Okay, let me try to find the first. Okay. So that's another example of a Thinkboard here. Okay. Here the concept is, say we want to teach what is 3 times 5 here. Okay. We want to teach what is 3 times 5. We want to teach 3 times 5 is 15. So we can represent this using an array model. Okay. This is a different representation. Each row is 5. There are 3 rows. So this actually means 3 times 5, 3 rows of 5. Here we have set model, 3 groups of 5. This also means 3 times 5 is 15. Here we are using the commutative property. We know that 3 times 5 is also equals to 5 times 3 based on the commutative property. Or we can write 3 times 5 also means 3 plus 3 plus 3 plus 3 plus 3 is 15. So 3 times 5 is 15. We have understood in many different ways. All these are called representation. Okay. Representations. Okay. So we have taught this using various representations. Okay. So this is the purpose of the Thinkboard, to teach mathematics concepts using various representations. Why? Because we want them to form connections. Okay. Sorry. because we want them to form connections. Because children learn better by forming connections. When they form connections, they learn for relational understanding. Okay, so that is all for the lecture today. Any questions?